Hello everyone, welcome to Eduxcite classes. My name is Monit, and in today's session we will solve the specimen paper for the year 2025 first assessment. Okay, so just be with me in the whole video, and it's a request to solve the questions for the paper 1A. In today's video we will solve the MCQ paper 1A for your IBDP 2025 specimen paper. Okay, so without wasting time, let us start. So with the very first question, a car has an initial speed of 16 meter per second. So we have the initial speed as 16 meter per second, and a deceleration A is given to us as 4 meter per second square until its stop, means final velocity is 0. Find the distance traveled. So we have the Suvert equation, v square equals to u square plus 2as. Putting up the values, so 2 minus of 4 because it's a deceleration, and s we have to find out. So this can be written as 16 into 16 divided by 8 is equals to s. So this is equals to 32 meter. Simple calculation, and this time you are allowed to use the calculator in your paper 1 as well with the data booklet. Okay, so make sure while watching this video, if you have not having your data booklet with you, please keep it with you right now, so that you will get to know what formulas are there and how to use those formulas. Okay, so option C is the right answer. Question number 2, a block of mass 2 kg accelerate from speed, so this is my initial speed, to speed 20, which is my final, without changing its direction. Calculate the impulse. Now we know that impulse is what? Impulse is the change in momentum. Okay, and change in momentum is final momentum minus initial momentum. As mass is constant, so final is 20, initial is 15, so that will be 10 Newton second. Very easy. Option C is the right answer. Okay, now question number 3, a net force of 8 Newton accelerate 4 kg body from rest. Again, rest stands for initial velocity 0 to a speed of 5, which is your final speed. Okay, what is the work done by the force? Now we know that from the work energy principle, work done is equals to change in kinetic energy. Okay, so how can we find out? Work done will be half m final square minus initial square, that is a change in kinetic energy. So 1 by 2 times kinetic energy is mass is 4 kg, initial final is 5 square minus 0 square, so that is 1 by 2 into 4 into 25. So this is 25 into 2, which is 50 joule. So option A is the right answer. Okay, a person stands on an elevator. The total mass of the person plus the elevator is 800 kg. The elevator accelerate upward at a acceleration of 2. So we know that there will be a tension, and overall elevator plus this will have a force mg in the downward. So I can write down equation T minus mg is equals to ma. Now this is one of the most common equation I have used in all my previous videos as well, and I have explained in detail. Just to give you a complete those who are watching for the very first time, always remember this equation, that driving force, dF, stands for driving force minus resistive force, will be equals to the mass into acceleration, the total mass of the system into acceleration. Now driving force are the forces which acts in the direction of the motion. Now you can see the system is moving in the upward direction, right? So this will be considered as the driving force. So I have written T as tension as the driving force, minus the forces which are acting in the opposite direction of the motion are resistive forces. So the opposite direction is the complete weight of elevator plus the person itself, whose combined mass is given to us, into g is the gravitational acceleration, is equals to the complete mass of the system, which is again 800, into acceleration, which is given as the a. So this is nothing but the net force acting on the object that we have considered. Now we have to find out tension. So tension will be what? Tension will be ma plus mg. M is 800, this will be 2 plus, for simply calculation you can take tan, or if you have calci you can just calculate. I am taking a rough idea. So 12 into 8 will be 9600 Newton, which is nothing but 9.6 kilonewton. Option D is the right answer. Okay, easy. So please remember this equation. This is very, very important. And if you have any doubt, and if you want a personal session with me, you can contact the number given below, or you can check the description. Okay. Now question number 6. An object is released from the rest in a vacuum at a height h above the earth's surface. So let us say this is the earth's surface and this is the height h. So an object is, this is the object. So this is released from rest, and object fall as it passes at a point at a height of 0.75 h. Let us say this is a point of 0.75 h from the above the surface. Okay, what is the ratio of the kinetic energy of the object at a height of 0.75 h to the gravitational potential energy of the object at h? So first what we can do is, the kinetic energy will be equals to the loss in gravitational potential energy at this point. So I can say loss in will be this much. So the change in height is how much? 0.25 h. So this is the delta h, right? So loss in gravitational potential energy is mg into delta h, and this will be equals to the kinetic energy at this point. So this will be how much? This will be mg into 0.25 of h. So I got this value. Now gravitational potential energy of the object at height h is nothing but mg h. So I just want to do the ratio, which is mg h into 0.25 upon mg h. So this and this gets cancelled. 0.25 is nothing but 1 by 4. So option B is the right answer. Okay. Okay, now question number 8. A bird of weight W on a thin rope at its midpoint. Okay, the rope is almost horizontal and has a negligible mass. The tension in the rope. Now in such type of question, please be very careful. Now what will happen? The tension will be like this. So if I draw the free body diagram, so let us say this is a very small angle theta. Both angles are same because it is at the midpoint. So if I resolve this, what will I will get? So this will be t cos theta. This will be t cos theta. This will be 2 times of t sin theta, because both the component t sin theta as well as t sin theta will be in the upward direction. Always remember, if this is tension T, this is angle theta. So along the horizontal or along the theta, the component will be t cos theta. If you know how to resolve the forces, that is very simple. If you don't know, just check one of my videos. I will pin it here so that you can refer that in order to get how to resolve the forces. Okay. So as of now, let us consider this 2t sin theta and this w. Now what will happen? This and this will get balanced and it will get cancelled out. So I can make a equation as 2t sin theta is equals to w. Now I have to comment over t. So t can be written as w upon 2 sin theta. Now it is very important to note here, the rope is almost horizontal. So it means theta will be very, very small. Now if theta is very, very small, the sin theta will be nearly equals to 0.01 or something like that. Now if you multiply this, you will get tension will be greater than w. You can check for very small angle, like if theta is equals to 1 degree. I have a calci with me. So for example, if I take sine 1, so this will be sine 1, almost horizontal means it is very near to 0 degree. Not exactly 0 but near. So I am taking, for assuming I am taking theta as 1 degree. Okay. So sine 1 is w upon 2 into 0.017. So if I multiply this with 2, and if I now wait, let us say anything it can be. So this 1 upon this will be gives you 28.6 times of w. So it is greater than. So that you have to keep in mind for very small angle. So it will always be greater than w. Okay. Okay. Now question number 10. The internal energy of a real gas. It's a direct question. The internal energy, always remember, is the sum of total potential energy plus kinetic energy. It's the sum of both. Okay. So it is equal to the sum of intermolecular potential energy and the total kinetic energy of the particles. Always remember. A black body radiation of an object at 600 Kelvin is given to us. The intensity are arbitrary. What is the radiation curve of the 450? Now you can see temperature has decreased. Now again there is a relation is given in your data booklet. If you go through, if you go through B.1, it is mentioned as lambda max. This is nothing but Wien's displacement law is equals to 2.9 10 raised to the power minus 3 milli Kelvin. Okay. Now what is this? This is meter Kelvin, sorry. Now this is what? This is nothing but lambda maximum and temperature, the product of maximum wavelength. Maximum wavelength means the most number of radiation that are emitted out from the black body, the maximum number of wavelength, that is the maximum wavelength into temperature of that black body is always a constant. Now when it was 600, the original curve was a dashed line. Now when it was 600, the lambda was lambda 1, let us say. Now this temperature has decreased, so lambda maximum will increase, so it will shift towards the right hand side, this side. So the new curve will have shifted, the lambda maximum will be greater than which was initially at 600. So this is at 600, so this is shifted that side, incorrect. This is might be correct, because yes, this is the same, incorrect, this is also incorrect, this is also same, incorrect. So this you can see it is as shifted from this part. So this lambda maximum which is at 450 is greater than the lambda maximum at 600. So option A is the right answer. Okay. Now question number 14, again no need to remember the formula. There are two star X having a luminosity L and apparent brightness B, and star X is at a distance of d from the earth. Similarly, Y has the same apparent brightness as X, but it is 4 times more luminous. What is the distance of star Y from the earth? So there is a formula given in your data booklet. Luminosity is equals to, or the apparent brightness is equals to luminosity upon 4 pi into d square. So they have the same brightness, apparent brightness. So I can say the B is equals to, so Bx is equals to By. So if I equate this, luminosity L x and also L x is equals to x, but is 4 times more luminous. So 4 times, so you can say Ly is equals to 4 times of Lx. Okay. So Lx upon 4 pi d square is equals to Ly upon 4 pi into dy square. So dy we have to find it out, right? So I can say now 4 pi and 4 pi gets cancelled. Ly can be written as 4 times of Lx. So Lx and Lx is gets cancelled. So I can say dy square is equals to 4 times of d square. So dy is equals to 2d. So option B is the right answer. Okay. Simple calculations are involved. Again 4 identical resistor, effective resistance between P and Q. So these are R, R, R. So this will become R and it's connected in parallel. This will become 3R. So simple 1 upon R, effective resistance will be 1 upon R plus 1 upon 3R. So this will be nothing but, so this will be 3R, this will be 3 plus 1 equals to 1 upon R effective. So R effective will be nothing but 3R upon 4. So option A is the right answer, simple one. Question number 16, a conductor X is connected to a cell of EMF E. The power is 16 watt is dissipated in X. So power is given to us. So power of X is 16 watt. EMF is given. The conductor conductor Y is made of the same material with same diameter as X, but it is twice as long as A. twice as long. A cell of EMF 2 is E is connected to Y. Both cell has negligible internal resistance. The power dissipated in Y will be. So we know that power is equals to V square by R, right? So this can be written as for X 16 equals to E square by, let us say the resistance is R for X. Now resistance of this is for Px. Now Py can be written as how much? It will be 2E square by R. Now R for Y will be, it is relation, same material means resistivity is same, diameter means area of cross section width. So twice as long. So this will be 2 times of R x, this is R x, right? So I can say 2 times of R x, because the length gets doubled, so the resistance will also get doubled from x. So if you compare this, it will become 4E square upon 2R x, and E square by R x is nothing but 16. So I can say Py is equals to 4 by 2 times of 16, which is equals to 32 watt. So option C is the right answer. So just relate what informations are given in the question and accordingly you can solve. Okay, so 16 is answer C. Now question number 17, again two container X and Y are filled with ideal gas at same pressure. So pressure of Px is equals to Py. Ideal gas is given, so we can use the ideal gas equation here. Volume of X is 4 times the volume of Y. The temperature is 6 Tx. So temperature in Kelvin we have to use. To 273 you have to add, which is 600 Kelvin, and the temperature of Ty will be 300 Kelvin. 273 plus degrees Celsius will give you in temperature in Kelvin. So amount of X, so we know that PV is equals to nRT. So N can be written as PV over RT. Okay, so pressure and R are constant, so we can say Vx upon Tx. This will be amount of X, amount of Y. Now amount I can relate with the number of moles, that doesn't matter because the same containers are there. So Vx upon Tx will be or you can write like this if you didn't get. So Vx upon Tx will be equals to Vy upon Ty. So rewriting Vx upon Tx, here it will go Ty upon Vy. Now just replace whatever the relations are given. Vx is 4 times of Vy, so 4 Vy upon Tx is 600 into Ty is 300 upon Vy. So Vy and Vy gets cancelled, this is 1, this is 2, this is 2. So you will get option C. Simple calculations, just you can take the screenshot, and if you have doubt you can just comment below. Even the PDF of this video is available, you can directly download, the link is given in the description. Now question number 18, an electromagnetic wave has a wavelength that is about the size of a diameter. Now you should know as a student, diameter of an atom is 10 raised to power minus 10 meter, and this time in your data booklet all electromagnetic radiation diagram is given, so you can check which region of the electromagnetic spectrum does the wave belong to. So if you check, this will be nothing but the X-ray. So it is given in your data booklet, you can check. So option D is the right answer. A particle undergoes simple harmonic motion of time period t. At time t0, the particle is at its equilibrium position. So we can make any, let us say this is a simple pendulum. So this is at t equals to 0. Okay, when t, what is t when the particle has its greatest distance from the equilibrium position? So greatest distance will be either this one or either this one. So from here till here it will take, if total time period is t, it will take t by 4, again t by 4 and 3t by 4 and then at t. So there are two possibilities, either t by 4 or 3t by 4. So just check the option, only one option is there, 3t by 4, there is no t by 4. So that will be the time at which it will be the greatest distance, that is extreme position. Okay. Question number 20. This is diagram 1. of displacement versus position of a standing wave which is forming on a string. Diagram 2 is nothing but the same position versus displacement versus position of a traveling wave which is moving to right along the string. This is very important. Now point P, Q, R, S are given. What is the phase difference between P and Q? Always remember P and Q are here, both will move in, you can see they are along the same line. They will both move in the upward direction at the same position. So the phase difference between P and Q will be 0. So either option A or option C. Now check R and S. Now as you see, it is a traveling wave, so it will move like this. So it will move in a little bit forward. So I can write it will be somewhat like this, right? So the position on R will be moving upward and the position on the S will be moving downward. So you can see one is moving upward, one is moving downward. So the phase difference will be pi by 2, which is 90 degree. So you can see option C is the right answer. So if it is moving, how I draw this? If it is moving forward, you can just say this crest will move in this part. So what you can do is you can mark 1 point here and 1 point here. So here the crest is here, okay, just see, here the crest is here, you can draw the crest here at this time, and here the crest is here, you can draw the crest here. So and just draw a simple traveling wave joining the crest. So because it is moving towards the right hand side. So this is the easiest way. Now again, for natural frequency of the oscillation, if a mass of 0.25 kg hangs on a spring of constant 4, so time period is equals to 2 pi under root m by k. This is the formula given in your data booklet. You can check, and we know that once we find out the time period, we can find out the frequency, because frequency is equals to 1 upon time period. We just reciprocal. So 2 pi under root, mass is 0.25, which is 1 by 4, and k is nothing but 4 only. So this will become 2 pi by 4. This is pi by 2. So frequency will be 1 upon pi by 2, which is 2 by pi. Option, 2 by pi, pi is 3. You have the calci with you, so you can check 2 divided by pi is nothing but 0.636. So frequency is 0.6366 Hertz, nothing but option B is the right answer. Okay. Now question number 26, there are two long parallel wires P and Q which are at distance d apart. They each carry the same current I. The magnetic force per unit length F acts on P due to Q. The distance between the wires is increased to 2d and the current is decreased to I by 2. What is the magnetic force per unit length that acts on P due to Q after the changes? So first it is given in your data booklet. Again, no need to remember the formula. If you go to the formula, D.3 motion in electromagnetic field. So if you go to D.3, the formula force per unit length is equals to nu naught I1 I2 upon 2 pi r. Okay, r is nothing but the distance. So for this I can write the force per unit length F, this whole value is F. So for F is equals to u naught I square, because both I1 and I2 are same, is equals to 2 pi d. Now we have to rewrite F dash will be equals to u naught I into I by 2 times 2 pi into 2d. So if I simplify this, I will get nu naught I square upon 2 pi d into 2 into 2. So this will become F by 4. Option B is the right answer. Okay, just a simple calculation. You can take a screenshot. Okay, now question number 28. Planet X and Y orbit the same star. Okay, then the relation is given that the distance of X is 5 times the distance of Y from the star. The planet X and the star equals to 5 times the planet distance between the Y and the star. Now we have to find out the ratio of the orbital period of planet X to the Y. So we know that a formula is given in your data booklet, V orbital. Okay, V orbital is under root of g m by r. So, and V orbital is nothing but 2 pi r over t. Okay, so the distance, and you can say this is nothing but the r only, the distance r x, and this is r y. So I can rewrite this equation as 2 pi r x upon t x is equals to under root of g mass of the star upon r small r x upon 2 pi r y upon t y is equals to under root of g m upon r y. Okay, so till it is clear. Now squaring both the side, now we can cancel this at least. 2 pi gets cancelled. So squaring both the side will get r x square upon t x square upon r y square upon t y square is equals to g m upon r x upon g m upon r y. Right, now g m and g m gets cancelled. So we get an equation of r x square upon t x square into t y square upon r y square equals to r y upon r x, right. So this will become r x cube upon r y cube equals to t x square upon t y square. Now r x is 5 r y cube upon r y cube is equals to t x square upon t y square. So what you can do is this r y cube and r y cube will get cancelled. This will become 5 cube equals to t x upon t y whole square. So that will be, this will be 5 cube t x upon t y, option D. So 28, option D is the right answer. You just have to do the calculation accordingly. Okay, you can take the screenshot if you want. Now question number 31. If you look at this diagram, we have to find out the charge on the rod and the charge induced on the metal sphere. So in this case, it is given that the direction of conventional current is this. So current is flowing in this, it means electrons are flowing into the metal sphere. So if the electrons are flowing into the metal sphere, it means that initially it was positive here and it was negative here. So if it is one negative, this will be positive, then only this can become negative here, because it will attract the free electrons from the metal sphere on this side. Therefore there is a deficiency of the electron. As a result, the electron moves in this side and the direction of conventional current is this. So what will happen, the electrons, once it will move here, this will neutralize the positive. So this will be, and so charged rod will be positive and induced charge will be negative. Simple. Okay. A positive point charge of magnitude 1 microcoulomb and a point charge q are separated by distance d. An electron is placed at a distance d from this. The electric force on the electron is 0. So you can see the electric force will be 0. It means due to this it will attract, because it is positive, it is negative, and this has to be negative, then only it will repel. So options C and D are incorrect directly without any calculation, you can see. Now we have to calculate, as I can say at this point, due to I will equate the forces. So K 1 into 10 raised to power minus 6, or let me consider in 10 raised to power minus 6 only. So 1 into Q1 into electron is 1.6 into 10 raised to power minus 19 upon d square. Okay, this will be equals to K Q into 1.6 into 10 raised to power minus 19, and the distance will be 2d, that will be 4d square, 2d ka whole square. So K and K gets cancelled, this and this gets cancelled. So Q can be written as 4d square upon d square. So this will be in microcoulomb, and negative we already considered. So option A is the right answer. Okay. Now it's a direct question. The sequence of the evolution of the main star, it is started for red giant for 2 solar masses, then the planetary nebula, and then the white dwarf. Okay. So option B is the right answer. You will study this in the astrophysics part. Now this is very interesting. The diagram shows the emission of a spectrum of an atom. This is the increasing wavelength. Now if I number this 1, 2, 3, 4, 5, 6 emission spectrum are considering in this diagram. Which of the following of the energy level? So we know that E2 minus E1, the difference in the energy level is equals to Hc by lambda. So lambda can be written as Hc over E2 minus E1. So what I can say is, lesser the difference in the energy level, more will be the wavelength. So for 6, I can say the least is, let us say this is the least 6, because this is the least energy level difference. So this will be the maximum wavelength, and 5 can be considered as this because these are very close. Okay, so 5 and 6 is this one. Rest is not possible in any of the case, because these are has to be the similar and very close, and that to be very small energy level, then only the wavelength will be, two wavelength will be maximum. This is not possible in this, this is not possible in this, this is not possible in this. So option A is the right. You can check for other two also. 4, you can see this will be the 4. Okay, 2 and 3 are very close, so 1 will be like this, let us say 2, and this will be 3, and 1 will be from top to the bottom. Maximum energy level difference, least wavelength. So option A is the right answer for this. You have to solve like this. This is the easiest way to solve questions like this. Okay. Okay, now question number 23 SL. The two radioactive sample X and Y have the same half-life. Initially the ratio of X to the ratio of Y is given to us is 4. Okay, so we have to find out what is this ratio after two half-life. So let us consider the ratio initially has AX and initially it is AY. So after one half-life the activity will be AX by 2 and this will also be AY by 2. After one more half-life it will be AX by 4 and this will be AY by 4. So this and this gets cancelled, so it will remain AX upon AY, which is given to us as 4. So there will be no change, or in other words you can remember that with respect to the half-life the activity also gets half. So after two half-life there will be no change in the ratio, it will remain 4. So option D is the right answer. Okay. Now question number 36, nuclear fusion reactor. It's a theoretical part. Just read all the three statements. Which of the statement is correct for the reactor? So the heat exchanger transfer energy from the fuel rods to the moderator. No, the heat exchanger is used to transfer the energy of the reaction from the water to convert that into the steam. Okay, so that is not the role of the heat exchanger, so this is incorrect. The control rod must be good absorbers of the neutrons. Yeah, the purpose of control rod is to control the reaction, which is depending upon the absorption of the neutrons. So this is correct. The moderator must slow neutrons down. Yeah, the moderator role is to slow down the kinetic energy when they are emitted. So 2 and 3 are correct. Option C is the right answer. Okay. Question number 37. There are two star X and Y and HR diagram is given to you. So X is at this temperature, Y is at this temperature, luminosity is constant. What is the radius of X to the radius of Y? So there is no worry, there is a formula given in your data booklet. I will let you know. The luminosity formula is given, sorry, this is given in, yeah, if you go to B.1, luminosity is equals to sigma A T raised to power 4. So if you use this, okay, so luminosity is same, so I can say of 2 star, this is a constant, so Lx is equals to Ly. So area is R, depending upon star is assuming as the sphere, So 4 pi r square, 4 pi is again constant, so I can say rx square into t raised to power 4 is equals to ry square into ty raised to power 4. So this relation you can use. Now just solve rx square upon ry square will be ty raised to power 4 upon tx raised to power 4. So put up the values. Ty is 10,000 square upon 40,000 square. So once you solve this and take the square root, this will be power 4, this will be power 4. So you can write down this as 10 into 10 raised to power 3, or you can just solve in your calculator, and once you do and then you make a square root of this, will get rx upon ry as nothing but option 1 by 16. 1 by 16, or you can do like this also. If you square root both the side, will become square and square, and then you can solve. This will be 4 into 4 only, rest all zeros are get cancelled. So 1 by 16, option A is the right answer. Okay,